This is Senior Algebra, section 6.4. Today we are factoring special polynomials here. So, in this section we're looking at some specific polynomials that give us some different factors, something that you may not have to do by either guess and check or by factor by grouping. So, things I look at here. I look at this and I go, there are only two terms. Now, we've seen this once or twice before, but we know that there was only two terms. Now, you could put a 0x in there. That would be fine. But what do we know? We're looking for a number that multiplies to negative 36 and adds to 0. So, we know the first one is x and x, but what multiplies to negative 36? Well, we know it's going to be a negative and a positive. And if we wanted 0, well, they have to be the same number. So, what's the same number, or what's the square root of 36? 6 and 6, because 6 times 6 is 36. So when you see that, a difference like that, you can think of it like this. X squared minus 4, it's known as a difference. Difference means subtraction of two squares. We have x squared, and then we have 4. Well, how can I think of 4? I can think of 4 as 2 squared. So, what is this going to factor into? They're going to be the same, except one's positive, one's negative, and it has to be 2. So, it's going to be that number in there, because 2 times negative 2 is negative 4, and the middle term drops out. So, I look at C, and I have x squared plus 16. So, if I think about it, I go x and x, of course. And then, okay, 16, that's plus 16 and plus 16, so that's plus 4 here. The problem is this, when I multiply it out and I just check it here, I get plus 4x in the middle and I get plus 4x in the middle. Well, does that cancel out? No, that gives me 8x here. Well, that's not what I wanted. I want the middle term to drop out. Well, how does that happen? One has to be positive, one has to be negative. So, what do we know? The 8x doesn't work. Because it's a plus 16, either it has to be plus plus or minus minus. So the middle term would never drop out. We say this is unfactorable or not factorable. Or we could say it's prime. Either one would be okay. All right, so the second one, D here, if I look, now this one has 3 terms. So we know it's not a difference of 2 squares here. But there is still a pattern to see here. If I see 25, I should always know my perfect squares, right? 4, 9, 16, 25, etc. here. Well, 25, that's 5 here. So I know it's x and x, and I'm going to try 5 and 5 here. It's 2 positives because it's a positive 10 in there. So it's really 5 squared, which is 25, and the 10 is double 5, or 2 times 5. So notice the 5s are the same there. Now again, you can just as easily do guess and check with this. That would be fine. You could just as easily factor by grouping. That would be fine too. In E, all right, 2 terms. It's a difference of 2 squares, DOTS. So 4x squared, oh, that's 2x squared, and 25, that's 5 squared. So my 2 terms are going to be 2x minus 5 and 2x plus 5. They're going to be the same thing, except one's positive and one is negative. And notice, if I was to multiply this out, what would happen to the middle term? Well, I would get a 2x and 2x, that's 4x squared. 2x times 5, which is 10x. Negative 5 times 2, which is negative 10x, and negative 25. The middle term is 10x and negative 10x. Well, that becomes 0. They cancel each other out. So what am I left with? The 4x squared plus 25, or 4x squared minus 25. It should be minus. I have plus. I'm wrong. So it's 4x squared minus 25. In F, now we have some x's and some y's here. Now again, this might be difficult to factor, okay, but something to look for is this. I see a 9 and I see 16. I should always think, oh, maybe it is a perfect squares here. So 9, well, what is that? That's 3 and 3. What about 16? That's 4 and 4. I know it's going to be minus minus here. So the first ones I'm going to try are 3x and 3x. Okay. So notice 9 is 3 squared, 4 is 4 squared. Well, if I do 3x and 3x, and I do minus 4y and minus 4y, look at what happens to my middle term. My middle term is twice the 3 times 4. 3 and 4 is 12, so twice 3 and 4 is 12. Notice here, when I multiply this out, I'm going to get a minus 12xy and a minus 12xy. So that's why it's double 12, or 2 times 12. And notice my first and last terms are correct as well. So it does check out. So the answer is 3x minus 4 and 3x minus 4. You could write that as 3x minus 4 squared. We'll take a look at that in a later example. So generally, when we have a couple things, when we have a difference, meaning subtraction, and we have perfect squares, we can just write it as a perfect square. So if I look, x squared, okay, but 9, I could think of it as 3 squared. So what are the two factors? X minus 3, x plus 3. If I multiplied it out, the middle term would drop out. Notice one's minus, one's plus. In B, I have x squared minus 64. It's a difference. There's two terms, so the middle term drops out. 64, oh, that's 8 and 8. Notice x times x is x squared, minus 8x plus 8x. That cancels out, and I get minus 64. In C, I have 16 and 49. Okay, well, 16 is 4x and 4x. 49 is 7 and 7. So I have 4x minus 7 and 4x plus 7. If I was to check this, I'd get 16x squared minus 28x and plus 28x in the inside and two middle terms. Then my last one would be minus 49. Notice the middle terms drop out, and I have 16x squared minus 49. So that's going to be my final answer. So if I look at example 3 here, I look at the 9 here. Well, 9 is 3 squared. So if we look at factoring perfect trinomials, things I look for. All right, it's a positive 9, which means either plus plus or minus minus. I'm going to look at it and I'm going to go, okay, well, x squared. Notice here, if the middle term is positive, it's going to be plus plus. If the middle term is negative, it's going to be minus minus. So in this one, I know it's going to be plus plus. And if I look, I'm going to have x and x. And now I could have 9 and 1, 3 and 3. Now, of course, it's going to be 3 and 3 because 3x plus 3x is 6x here. So I got the 3x there. I got the 3x there. That's where I get my middle term 6x from. Notice it's double 3 and x. So that's where, if you look above, it has the 2 there. That's why it's double the first and the last ones. 2 times, and the first one is x, and then 9, that's 3 squared, so 3. Now again, for me, I think it's just as easy to not worry about the rules here and just go ahead and factor it like you have. Either do guess and check or factor by grouping. It's not a bad thing to recognize, but hey, you can factor it just as well. So if I look at this one, I have 4 and I have 81. Well, 4 is 2 squared. 81 is 9 squared. So I think maybe it is a perfect square, meaning what? They're both the same. 2x minus 9, 2x minus 9. Why is it minus? Because the middle term is negative. Now notice if I took a look here, I can write this as 2x minus 9 squared. If I wanted to, I could check it, and I would see that, yes, that is correct.